welcome to Aeronexus. Today we are kicking off the FS Academy Interceptor program in Microsoft Flight Simulator 2024. Lesson 1 is all about stepping into IFR flying. That'll take you right along this journey. So what's IFR? It stands for Instrument Flight Rules compared to VFR, which are the visual flight rules. There's a big difference between VFR and IFR, of course. VFR only allows you to fly in visual flight conditions. It's mostly nice weather outside. Compared to IFR, where you're also allowed to use IFR when it's nice weather. So, of course, you can fly IFR anytime, though we want to specifically train with this mission pack parts where you don't see out of the window a lot and you need to rely on the instruments. And it feels very different, it looks different, and you can't rely on your senses. So that's why in IFR training you spend a lot of time to not trust your own senses necessarily, but trust the instruments. In this first mission I'll be setting up the cockpit. We jump right into the scan of instruments. There will not be a lot of explanations by me in this session, given that we have fantastic explanation by the flight instructor in the missions. We will do other mission packs as well, and I spent a bit more time explaining than the theory behind it. So you will be seeing mistakes I will make. I go through this program the first time as well. And if you're flying along with FS Academy 2, let me know. Drop a comment and share your experience with the community. And if you're new here, make sure you subscribe. I'm really excited to share my flying experiences with you. We'll be flying through every single lesson in this series and love to hear from you. So, alright, enough talking. Let's get into the cockpit and start lesson 1.
On first contact. This is Jersey Information Delta at time 1500 Zulu. Runway in use. 26. Surface wind 200 degrees 10 knots. Visibility 1000 meters in mist. Moderate rain. Cloud broken at 900 feet. Temperature 9 degrees. 2.7 degrees. QNH 1005 hectopascal. No significant change. Runway surface is wet, wet, wet. Advise ATC you have copied information, Delta, and advise aircraft type on first contact. This is...
As the weather tightens its grip, the clouds grow denser and descend lower, while the rain intensifies, cloaking the landscape in a mist that gradually erases the horizon from view. Pilots reliant upon visual flight rules, VFR, are left with no choice but to ground their aircraft, as they are ensnared in a waiting game for the skies to clear. But not us. Armed with an instrument rating, we unlock an opportunity to fly anywhere, day or night, rain or shine. This is FS Academy Interceptor. Above us, the sky is crisscrossed with a vast network of invisible aerial pathways. Navigating this other world is more than a science, it is an art. For each tutorial, keep the on-screen Mission Steps panel visible, as it provides step-by-step, real-time instructions tailored to guide you through the session. Our first step is to familiarise you with these critical tools from the viewpoint of an IFR pilot. Front and centre on your instrument panel is the attitude indicator, the AI. This artificial horizon communicates all-important precise pitch and roll angles. We can see that the sky is represented by blue and the ground by brown. Pitch angle marks are shown above and below the horizon line, while bank angle marks are located along the top of the instrument. The first roll marks from the centre represent 10 degrees of bank, then 20, followed by 30 and 60 degrees. Most turns that we will be performing will be at around 17 degrees of bank. Below and to the left of the AI is the turn coordinator. All major turns we make during Instrument Flight Rules IFR procedures will be rate 1 turns. This equates to a heading change of 3 degrees per second. By turning in this way, we would complete a 180 in 1 minute exactly, therefore a 360 in 2 minutes, as is written on the dial face itself. When the aircraft wings on the turn coordinator align with the white marks, we are turning at rate 1. Except for minor corrections, we will always target rate 1 turns. Primary reference to the rate of turn will be achieved through the bank angle indication on the attitude indicator, with the turn coordinator a secondary check. The side slip indicator is located at the bottom of the turn coordinator and shows if we are correctly using gentle pressure on the rudder to supplement our turning, keeping the aircraft in balance. To the right of the AI is the altimeter. This instrument senses the outside air pressure. Pressure reduces as we climb, with the altimeter designed to display this pressure as an altitude indication in feet. Air pressure also changes with the weather, so we must keep the altimeter updated with the correct reference pressure in order to achieve an accurate reading. This pressure is reported to us in the airfield weather report as a QNH, which is the air pressure at sea level. When the correct QNH is set, we will observe our height above sea level on the dial, which is our altitude. Parked on the tarmac here in Jersey, we are above sea level. We therefore see the airfield elevation of 277 feet displayed on the dial. Each hectopascal increment in QNH corresponds to around 30 feet on the altimeter, so a precise setting is essential. Around the world, QNH may also be referred to as the altimeter setting and can be reported in inches of mercury. Below the AI, we find our heading indicator. This may be represented by a simple directional gyro, as seen here, or a more advanced horizontal situation indicator, HSI, as found with more modern avionics. Turning to and maintaining a desired heading is a cornerstone of instrument flight, as achieving a prescribed path over the ground underpins every IFR procedure. Heading and track are two distinct properties. Heading represents the compass direction in which our aircraft's nose is pointed, whereas track is our direction of travel over the ground. Without the presence of wind, heading and track are equivalent, but once wind drift becomes a factor, we must have a clear understanding of each, which will be discussed later in the course. To the left of the AI, we find our airspeed indicator, ASI. This operates as a pressure gauge, converting the force of the oncoming airflow into an airspeed reading. Both our speed through the air and our speed over the ground are important for IFR flight. This will come into play later on when we introduce wind effects and start to climb towards the thinner atmosphere found at greater altitudes. Down and to the right of the AI, we find the vertical speed indicator, VSI. This measures the rate of change in air pressure displayed as a vertical speed in feet per minute. When descending down the approach path towards a runway, we will be mindful of the rate of descent, as this is how we maintain a prescribed glide path. The AI is to be considered as king of instruments. For every manoeuvre we perform, it will be initiated by a change of pitch and roll, which will then be evidenced by the other instruments. The AI, ASI, altimeter, turn coordinator, heading indicator and VSI form what is commonly known as the six-pack. Over to the right of this cockpit, we have our navigation radios and automatic direction finder. A core concept of correctly tuning a radio beacon is to tune, identify and display. We set the frequency of the desired navigation aid, NavAid, into our navigation radio. Then we verify that the intended beacon is being received and is operating. We do this by enabling the ident function and listening to the identifier signal transmitted in Morse code. Once identified, we can begin to use the NavAid by displaying it on our instrumentation. As an example, we will tune, identify and display the Jersey Non-Directional Beacon, NDB. Use the 3 tuning knobs on the right side of the cockpit to dial 329 into our Automatic Direction Finder, ADF. Now that we have the station tuned, we need to identify the nav aid. Now we listen to the Morse code identifier. We check that the nav aid identifier code is being received, which in the case of Jersey NDB is Juliet Whiskey. The NDB is now identified. We leave the audio enabled so that we can detect any failure of the beacon or of our ADF system. As there are no other failure flags or indications of abnormal behaviour on these analog instruments. Knowledge of Morse code is useful but not essential, as the dots and dashes are displayed on IFR charts alongside the nav aid's identifier letters and frequency. We see that the yellow pointer of the relative bearing indicator, RBI, has aligned itself with the direction to the NDB. This does not relate to the bearing indications that surround the instrument, as this is simply a rotatable compass card. Simply see it as a relative direction compared to the aircraft symbol at the centre of the dial. The needle currently shows the NDB to be at around 15 degrees to the left of the nose. Turning left to centre the needle and maintaining this position would fly us to the beacon, assuming there is no wind drift to account for. I will now turn off the ADF ident audio. Non-directional means that the beacon transmits a single signal in all directions. The ADF radio is only used for NDBs. Our stack of radio equipment has the communication radios down the left side and the nav radios on the right, with nav 1 on top and nav 2 below. To tune in a desired nav aid, we use the tuning knobs to dial in the frequency found on our charts. With nav radios, this sets the standby window of the radio, which can be made active by pressing the white swap button. Our nav radios are multi-purpose, as we can tune in a range of different nav aids depending on the task at hand. We will start with the VOR, the Very High Frequency Omnidirectional Range. Omnidirectional meaning that in contrast to the non-directional NDB, a VOR radiates a signal for each of the 360 compass bearings, which each bearing known as a radial. For instance, the signal projected on magnetic east aligns with the 090 degree radial, while the signal directed magnetic south is the 180 radial. To tune a frequency, we use the tuning knobs at the base of each nav radio. Use the knobs to dial in the Jersey VOR, frequency 112.2, into the nav 1 standby window. 112.2 is now set in the nav 1 standby window. Press the nav 1 swap button to make it the active frequency. As before, we've tuned the nav aid, now we must identify it. Along the top of the radio stack, press the nav 1 button to enable the Morse code audio ident. We hear the Morse code identifier and can match it with Juliet Sierra Yankee, the 3-letter code for Jersey VOR. With the VOR properly tuned and identified, its readings can be presented on our cockpit displays. Since we've set the VOR on the nav 1 radio, its guidance will appear on the nav 1 receiver. This instrument visualises our aircraft's deviation from a selected course in degrees, indicated by the vertical white needle, the Course Deviation Indicator, CDI. The needle can show up to 10 degrees of deviation to the left or right of course, with each dot on the dial representing 2 degrees. The first 2 degrees is shown by the edge of the circle at the centre of the instrument. To maintain our course, we fly towards the needle. For example, if the CDI needle is deflected to the right, we need to fly to the right to recapture our desired course. If the VOR station or nav receiver were to fail, we would be presented with a red failure flag on the face of the dial. This failure monitoring allows us to silence the ident. Please press the nav1 ident button again to turn off the audio. You can find the nav1 button along the row of buttons at the top of the radio stack. The swap button is the white button on the nav1 radio with the double arrowhead. At the bottom of the nav1 display, we see the OBS knob. OBS stands for Omni Bearing Selector and allows us to define a particular VOR radial that we wish to track, either to or from the beacon. We can also use the OBS to determine our relative bearing from the VOR, our radial, and therefore the direction to fly to reach the beacon. Turn the OBS knob clockwise until the CDI bar centres with a 2 indication, shown by a white triangle pointing upwards. This will be with 080 set at the top of the dial. With the CDI centred and 2 displayed, the top of the dial shows the course we would need to fly at this moment to track directly to the VOR. We see that this would be a course of 080 degrees. Turning to 080 would fly us towards the beacon. With the needle centred and a 2 indication, the bottom of the dial shows our current radial from the VOR. We read 260 from the bottom of the OBS dial, putting us on the 260 radial. Note that the radial we are on represents a magnetic bearing from the VOR and is unrelated to our heading. We could be flying in any direction, but our radial at that moment and the indication on the CDI remains unchanged. The nav receiver can also act as the display for the Instrument Landing System, ILS. This is a radio-based landing guidance system that projects a signal along the approach path to a runway. 2 radio beams make up the ILS, the localizer and the glide slope. When tuned to an ILS, the CDI represents the localizer, showing our deviation from the centre line. Think of it as a fly towards indication. If the bar starts to deviate to the left, you need to turn left to regain the approach path. This lateral indication is accompanied by vertical descent path guidance, emitted by the glide slope. This is displayed by the horizontal bar of our nav receiver and uses the same fly towards principle. If the bar starts to rise from the centre, we are getting low and need to reduce our rate of descent in order to recapture the correct descent angle, which is usually set at 3 degrees. Combining the localizer and glide slope forms the ILS and is a very precise and reliable landing system. Instrument flying requires focused attention and the prompt identification of any deviations from the intended parameters. Detecting discrepancies and drifting needles early allows for minor and more gradual adjustments, rather than abrupt and significant corrections. This is similar to balancing a pencil on your finger, where subtle and timely movements are more effective than large and erratic ones. Through consistent practice and experience, pilots develop the skill to understand and trust the silent guidance of their instruments. We will start with the basics and concentrate on building a solid foundation. Turn the OBS knob so that the CDI bar is centered and a 2 flag is shown. You completed this first tutorial perfectly. We will start the next lesson in flight, or your first encounter with the elements. Welcome to FS Academy Interceptor.
Tell me how your first lesson went and share in the comments. Make sure you subscribe so you don't miss the next mission. So thanks for watching Aeronexus. See you in the cockpit next time.